Is the screen visible? Hello, is the screen visible?
Yes, sir.
Yes, sir.
So in the last few classes, we have discussed about the open hardware platform like an Arduino, understood how to connect analog and digital devices and sensors to the Arduino board using its pins. Then we identified that there is a way to connect the open hardware platform to the virtual machine like a cloud platform so that it can store the data and make it accessible throughout the world, anywhere from anywhere. So for that, we migrated from Arduino board to the Node MCU, which is nothing but Arduino was just a microcontroller. When I migrated from Arduino to the Node MCU, so to start with, I've used Arduino. It is nothing but MC microcontroller. Then since I thought of making it IoT capable, I used Node MCU board. So Node MCU board was nothing but what? MC plus Wi-Fi was there. So that it provides the network infrastructure plus microcontroller, the thing capability, so that it was suitable for IoT. Now I'm coming to the next era where you don't require a microcontroller. That means that the microcontroller limitation is what? The computation capability. What speed it's going to work? Let's say 80 megahertz. What memory capacity? It's less, mind memory, we know that. The amount of RAM it provides is less. So generally microcontrollers are used to perform a lower compute intensive jobs because its computation capability is less, the mind memory is also less, the RAM capability is also less. But when you have a compute intensive, that is, my requirement is a lot of computation is involved. When I say a lot of computation, what does it mean that? So I have to take a picture, I want to take a photo, I want to do certain processing, I want to perform certain analysis of the data, whatever I've captured. I want to implement some web hosting, that is a web server with capabilities. That means that whenever my computation capabilities are more required, you cannot just use an MC. So you almost require what a computer is required. Almost you require a computer, but it should have the capability of what? Both the Arduino, that is, it should act as a microcontroller also. It should also act as what? The Wi-Fi capability also should provide. Along with that, you should provide what is called as computation capability. But can I use a normal laptop computer or a normal desktop computer? No, it cannot be an embedded system. An embedded system quality is what? It should be small. The power consumption should be less. It should be affordable. So normal computer laptop is always 30,000 plus. That means that it do not satisfy the requirement of an embedded system. So what is my requirement now? You should act, I want a computer which should have the capability of a microcontroller. What do you mean by capability of a microcontroller? You should provide me the pins, digital input output pins, so that through that I can talk to the external world. Normal desktop computer do not have that facility. Can you see any pins coming out of a normal desktop computer or a laptop computer? No, you cannot find them. Only the method maximum is what? USB. You can plug in USB and do some conversion, then you have to do it. There is no way I can put a jumper wire directly into a laptop or a desktop computer. That is why I say that the normal computer do not have the capability of a microcontroller. Even though it is more powerful than microcontroller, but do not provide me the flexibility of connecting to the external world. So, but what I want now, I want a computer in the sense, I want a computer like computation capability, like a normal computers are capable of doing image processing, capable of doing the graphics, so capable of doing so many things. So such capability I require, but you should act like a microcontroller. That means you should provide me facility to talk to the external world through set of pins, maybe analog and digital pins or PWM pins like that. Now, and also this computer, whatever I'm talking about, it should also provide me the network infrastructure so that I can connect to the internet. So I don't want the normal computer, but I want the capability of computer. So what is the capability of computer? First most requirement is put the whole computer on a single board. So then it becomes an embedded system. If you give a separate monitor, like a separate keyboard, separate mouse, separate, it cannot be an embedded system. What do you mean by embedded system? Integrate the whole thing on a single board. Can you put a hard disk? Can you put the peripheral interfaces, whatever required, everything on a single board? So then I can call that type of computer as called as single board computer. So now I'm looking for what? I'm looking for the next version of an embedded system, which is called as single board computers. What is the advantage of a single board computers? It has got the capability of a microcontroller. It has got the network infrastructure, that is Ethernet, Wi-Fi, all the facilities will be there. Plus, it provides OS installation. That means that whenever you use a single board computer, I can load OS on that. For example, a lot of Linux versions can be loaded on that. When you load OS on that, what is the advantage? You can run multi-thread programming, multiple applications can run at a time, a lot of libraries will be available, a lot of computation can be possible, a lot of work which cannot be possible on a microcontroller can be possible here. When you have a full-fledged OS, just imagine that it is nothing but like a normal computer. All the computation is possible, plus along with that capability of a microcontroller. So now my requirement is I have moved from Arduino microcontroller to Node MCU. I have moved from Node MCU now single board computer. So this single board computer, so one is requirement is, as I said, everything should be on the single board. Next cost should be less. So if I'm able to purchase 300, 400 rupees Arduino board, maybe Node MCU latest version or 700, 800 rupees, can I get a single board computer for, so can I get from 2 to 4K? So if I'm able to available at this one, and can it work on a battery? That means that can I hold my single board computer, can I run from a battery? Yes, then such a single board computer is meant for embedded system application or meant for IoT edge applications. That is, IoT means you require a thing, that is embedded system. That is, you require some hardware which is capable of capturing the data from the sensors, do some processing and send to the cloud. So such single board computers are very popular nowadays for implementing a lot of applications. This is also called as edge computing also nowadays. Now let's not move into the IoT concept. Let's understand what is the single board computer, what are the computers are available like that. So which one I have to go for it, how do you use them, how do you program that one. There are so many single board computers available from Intel, so many other companies. But the moment when you enter into the BE or even in the PUC, also people talking about nowadays what is called as a Raspberry Pi. So Raspberry Pi is a single board, such a single board computer, which has got the capability of a microcontroller, capability of a network infrastructure, capability of a computation, which supports a OS, which can run from a battery, and which is a cost less. In the sense, cost is not as much as a normal computers. So today we will be studying about the details about RPie, that is Raspberry Pi. So what is this and how it came into the market, and all those things we will study on that. So we will just study for a moment a cheat sheet released by one of the company about the Raspberry Pi, and then go to the PPT, and then we will write some programs. Then we will do some interfacing. We will connect on the sensor today, and we will just upload the data from the sensor to the ThinkSpeak cloud. Is it audible?
Yes, sir.
Yeah. Okay. So now we will move into some of the applications of the RPie. So how does it come? What is it? And then we'll go to the details, technical details of RPie. We will make some general discussion. So this is this sheet I'll share you. This is one of the very well compiled cheat sheet about the RPie. So done by Tech Republic. So we will see some of these things today before go to the technical details, that is writing the programs about the RPie. So what is basically an RPie? So they say that RPie is basically success. The whole success of the RPie defied the expectation. Nobody expected RPie would be this much successful. Conceived as an affordable computer for getting kids to learn how to code, it creates creators. Though they would sell 1,000, they would now sold more than 30 million. So in the sense, RPie was conceived as a low-cost computer to teach the students how to learn computer programming. That was their intention in the beginning. But later, they could not imagine RPie can be used and replace an Arduino board and people use for embedded system. Nobody has thought. They thought that it's a low-cost computer. But they thought they will sell around 1,000 pieces. But now their sales as 30 million has reached. In March 2020 alone, the company shipped 640,000 units. That is its second highest sales month on record. And with the arrival of the 8GP Model B, there's the latest model of the RPie, the single board RPie beginning to take on the mainstream PC market with an increasing gusto. In the sense, it is just a small project. Now it is becoming a competitor for the existing desktop computers. It has gone to such an existing level. Today, an engineering graduate without the knowledge of RPie means you're missing something. That means you're not learned some important aspect of engineering. And any engineer who is going out today of any discipline, you should have a complete control over the RPie, how to program it, use it. You should own one such. I'll tell you, you can miss anything in the life, but you should not miss one RPie. You should have your own RPie and you should do program on that. So that really helps you to build a lot of projects and gives a lot of confidence over the computer system itself, because it's not the computer microcontroller, it's a compute itself. So you can learn about the Linux, you can learn about the computer architecture, you can learn about IoT, you can learn about sensor integration, so many things you can learn once you have this board with you. Now, so what is RPie? This is one of the picture, one of the model of the RPie. This is how it looks, single board computer. When I say single board computer, if you would have seen in it by chance, the desktop computers, normal, if you open your system, laptop or a normal desktop computer, you can see a big motherboard. It is nothing but a same motherboard, which has been in a small miniature size, a small footprint size as it is being designed. And lot of cards, when you open your desktop, it's not only motherboard you see. On the motherboard, you can see small cards inserted in the motherboard. That means that the computer is built, not only one board, computer is built with what? One motherboard, then floppy disk controller card, hard disk controller card, display card, like so many other cards will be inserted on the motherboard. The whole thing will be a computer. Now what will happen here? The whole motherboard plus additional cards, whatever will be there to build a computer, will be inserted in a single board here. So that means that all the peripheral interfaces, which comes as an additional boards in a normal computer, are being gone into the same board. For example, Ethernet. See, the required Ethernet interface is completely provided here. The Ethernet interface related circuit should be there. That means that no additional board is required, because on the board itself, Ethernet circuit is there. For example, you have an SD card in the back side, SD card related interface is built into that one. So you can just power in the board, and start working. So the related USB to serial interface is what is required. It's already there inside. So whatever required to make one computer, the number of boards is being built in a single board. And this board, whatever built using the microcontroller, or you can call as a processor, should act like a microcontroller also, because you should give a feeling of an embedded system also, unlike a normal computer. That is why they provided a pins. So a lot of GPIO pins are provided here. Through that, you can talk to the external world, that is a sensor. With this type of programming, this type of interfacing is not possible in a normal computer motherboard. This is one of the advantage of Raspberry Pi. You can say that Raspberry Pi act like a microcontroller, also act like a computer in a single board. So what is the cost? They say it's $5,000. So you can get that lower versions around 1,800 rupees to 4,000 rupees. Between the 2 to 4K, you can get a variety of versions of RPie boards are available in the market now. So what does a Raspberry Pi do? A lot. Despite its low cost, the Pi can run as a no-frills PC. You can use it as a PC, a pocketable coding computer, a hub for homemade hardware, and more. If you have worked in RVCE lab, the ground floor lab, there's a lot of computers are there. These computers are connected to what? With an Ethernet. In the sense, they're through a cable, they're connected to a server. So in the lab, if you remember in the ground floor you work, you'll see a big monitor. But you will not see in some of the labs the hardware, that is, there is no CPU will be there. So CPU is bundled on the backside of the monitor itself. So they have used most of they're called thin client computers, thin client. In the sense, thin client means you have a display will be there, normal system unit will be there. Normal, you have a what is called system unit, which contains a hardware called as motherboard, cards, and everything. That will not be there. So you can see on the backside of a monitor itself, small box is there. So that box they've used Raspberry Pi. In a sense, Raspberry Pi is also used to build the normal PC, that is a thin clients. So today, most of the laboratories in the colleges, they use the thin clients as the computers. So for a thin client, it is available because the cost is what, 4,000 rupees plus add a monitor cost of another 4,000 rupees. For 10,000 rupees, your systems are ready. Because why? Much of the computation happens in the server. So thin client is what? It gives a front end for you. It loads most of the software sits on the hardware platform, that is a server platform. You provide an interface between your front end, that is a thin client, and your server platform. So for such applications also, RPie is used. So number of thin client computers today have been designed using a RPie. Why does RPie matter? The Pi is a great machine for stoking interest in programming among school children worldwide and helping create the next generation of developers. So who are the competitors? There are a lot of competitors now available, but still I'll tell you that RPie stands the best among them because of the lot of third-party support available for the RPie. So, okay. So let's learn about simple thing. What is a Raspberry Pi? RPie is a family of a credit card side single board computer that have become the best-selling UK computers of all time. Key to the Pi success has been its price. It is not the most powerful machine in the world, but for less than $60, it offers a computer that can use to build a homebrew electronics and put together a vast range of devices on a budget. The Charitable Foundations, you should remember why RPie is famous, because RPie is run, basically it's a very charitable foundation to start with. The Charitable Foundation behind the Pi has not rested on its laurels, upgrading the Pi specs 3 times since launch, while keeping the price $35 to $55. In that time, the Pi's processing power has grown more than tenfold, putting the Pi into the category of a machine that could be used on everyday PC. In hot specs, the top end model, Raspberry Pi Model B, this is the latest version, of course. We have a Raspberry Pi Zeros also. Raspberry Pi 4 is the latest model, Model B, has 1.5 gigahertz quad core. Just compare, where is Node MCU, where is Arduino, and where is RPie. So it runs on 1.5 gigahertz quad core. So 64-bit ARM Cortex A72, your Node MCU or Arduino are all 32-bit controllers. Look at this. There's 64-bit ARM Cortex A72. It's an application processor. It's not a microcontroller. A72 is what? It's an application processor with ARM. It's not a controller, but provides a facility to use to build controller projects. But it is an application processor. Cortex A72 based quad core processor, up to 8 GB RAM. How much of RAM we had? We had a very limited RAM of 256 kilobytes or like that in a microcontrollers. Maximum 1 kilobyte, 256 kilobytes, like a very less amount of RAM you have for storing your variables. Because that is why OS could not be loaded on Arduino, because loading on OS in Arduino requires a lot of RAM space. Look at the RAM space here, 8 GB RAM. It's uncomparable to the RAM whatever Node MCU or Arduino provides. Because of the huge RAM it provides, you can load a complete Linux version on the Raspberry Pi. For any OS to run, always you require a good amount of main memory is required. So that is an advantage of this one. A video core capable of 4K video playback, so that higher resolution and faster videos can be played. And network infrastructure, complete 802.11 AC Wi-Fi and gigabit Ethernet. It provides support for LAN also. It provides support for Wi-Fi also. In the sense, you can establish multiple RPie computers by using a cable, LAN cable, or you can establish a connection among the many Raspberry Pis and other computers using Wi-Fi also. So a complete network infrastructure is provided by this board. And 2 USB 2.0 USB 3 ports. So the normal computers which are capable of providing USB ports, because USB ports are the way to connect number of devices which is commercially available in the market. So these are the features. These are the features whatever I read now. Outbeats the capability of your Arduino and Node MCU boards. So summarizing that, I can tell you that. So number 1, it works at 1.5 gigahertz with 64-bit ARM Cortex A72. Number 2, it has got 8 GB RAM. Number 3, it supports video processing. Number 4, it supports network infrastructure by providing both the Wi-Fi and Ethernet. Number 5, it supports the USB ports, which were not there in your normal Arduino board. It has got a USB device, not as a USB host. That means that I cannot connect on a hard disk to your Arduino. So whereas here it's a USB host come device. In the sense, I can connect another hard disk itself to your RPie, so that I can store, I can extend my storage capability. So it acts as a host also, it acts as a device also. So what does the Raspberry Pi do? The Pi was created as an affordable machine that would help kids to learn how computers, but arguably become far more than that. You can use the Pi as a desktop PC replacement. Particularly, you can use the top-end 8 GB Raspberry Pi model 4B, though there is a myriad of possible use of the board. Media Center, some of the applications of Raspberry Pi is what? You can deploy RPie to develop a media center. You can use it as a file server. You can develop that RPie as a weather station, a virtual assistant, a smart home hub, high-performance clusters, virtual desktop thin client, a robot brain, Lego-powered book scanner, a retro games console, eye in the sky, drone guidance, low-cost ventilator. So these are around 10 applications they have listed here. Like that, hundreds of applications you can plan for the RPie. So RPie can be used for the media center, file server, weather station, virtual assistant, smart home hub, high performance clusters, virtual desktop thin client, robot brain, Lego powered book scanner, retro games console, eye in the sky, drone guidance, and low cost ventilator. So these are the number of applications which is possible using a RPie. So some of the general information. If none of these take your fancy, then there is always the option of using the wealth of programming-oriented software bundled with RPie's official Raspberry Pi OS, formerly Raspbian, to learn about coding and hardware hacking. So Raspberry Pi comes with its own operating system. That is, you can download. It's a free. You need not pay. For example, normal desktop computers, you have to pay for Windows. If you take an Apple, you have to pay for them. Yes or no? The beauty of RPie is what? The OS bundled with the board. That is, it's available on their website, Raspbian website. You can just download it free. That means that board comes with a free OS. That you should remember. That board comes with a free OS. In a normal desktop computer, whether you purchase from Apple or HP, anything, you have to pay for the OS. It's a completely free OS. So it's called as a Raspbian OS. Of course, a lot of Linux variations are also available for download. You can use them also. The Pi has been the bedrock of some spectacular creations and has even made the trip to the International Space Station. So setting the Pi is slightly different and possibly slightly more complex than your average computer desktop, though not by much. There is easy to follow guidelines, and the Noob's new out-of-box software installer makes getting the computer up and running relatively easy. So what does it mean that? That is, like a normal computer is easy for you. You go there, you go to the shop, you just book for your Lenovo laptop, you come and start using. It is easy to use and set up and install the software. Raspberry Pi is not like that. It requires a daytime to understand, because you're getting all the raw things. You're getting OS separately, you're getting the board separately. Yes or no? It is a third part. It's like a free platform, open platform. Whenever you go for an open platform hardware and software, you require some patience. How to use a board, what other things are there, how to use the software, how do you install it, and all those things are required. So anyway, we will have a session for that also. Once you have an RPie, what to do and everything. Of course, a lot of guidelines is available. You can refer that also. So the price of a Pi is born of a connection for some. Okay. Okay. Even nowadays, so you can even get a form of a Microsoft Windows to run on the cloud board. The Pi runs Windows 10 IoT Core, a cut down version of Windows 10, not designed to run desktop PC, but it's to help hardware hackers prototype Internet of Things appliances using Pi. So if somebody asks, can the Windows run? Yes, not the complete desktop version, but Windows IoT Core can be installed, and it's a free. Anybody can use that. Now, so once we have understood what is a Raspberry Pi, what is an applications, what is the latest version, everything. Now, it's systematically, let's from theory point of view, let's study with a one PPT. Now, is it audible? Hello.
Yes, sir.
Yes, sir.
So now I was just talking about, in general, about the RPie, why it is came into market, how it is different from Node MCU and RPie and everything. Now, systematically from theory point of view, let's learn that one in detail. So at the end of this session, maybe I would like to extend for some more time my class also. So at the end of maybe another 1 hour, you will be in a position to comfortably use Raspberry Pi to build a project. So that details I'll be covering now for the next 1 hour. Now, so this is the Raspberry Pi. If somebody asks, what are the Raspberry Pi consists of? So Raspberry Pi, so consists of following things. This you have to remember from the theory point of view. So what are the components present on the Raspberry Pi board? Number one, it has got a microcontroller. So I don't use a word called microcontroller. Now one word I use called a system on chip. A system on chip is powerful than a microcontroller. It is like a processor by itself. So which chip is being used in Raspberry Pi board initial versions? They use a Broadcom. So Broadcom is a number one company in the system on chip manufacturing. They supply the BCM2835 system on chip, so which is being used as the CPU or the microprocessor or a microcontroller of your Arduino board. So what is the chip used? BCM2835 system on chip is being used as the CPU of your RPie. The CPU handles all the computations that make a computer work, taking input, doing calculations, and producing the output. And the GPU handles the graphics output. So RPie comes with both the CPU and the GPU. GPU handles the graphics things, and the CPU handles all the computation. So BCM2835 is being used. Now, GPU. So I said Raspberry Pi provides a facility for the hackers and the hardware hobbyists to build a project. So they want to allow them to tinker their own projects. So now, how does it allows them? So these are the pins. So these are called as 40-pin GPU header. There are totally 40 pins are there. Pin numbers are counted 1, 2, 3, 4 like that. Up to 40 is there. So if somebody asks, what is the number? What is the size of a GPU header? It's a 40-pin GPU header. It provides all the input-output capability to talk to the external world. So we will discuss about what pins, what are the numbering and everything. So let's come to the next one. So first is it contains the BCM2835 system on chip. Second, it contains a 40-pin GPU pin so that I can talk to the external world for the sensors and devices. Third, RCA jog allows connection of analog TVs and other similar output devices. So in the original versions, they had a RCA jog also was available. Why RCA jog was required? So this is look at the jack. If you look at the old monitors, some of the video devices which are available in the market even today for access control system, they provide that type of monitors. They require this type of connector is required. Audio video jack is required. So this is used to connect old type of devices, video devices. So it's also called as RCA jack. So old TVs, even a lot of access control systems today comes with such TVs. So if you want to do any project using analog TVs, yes, you can say that, yes, Raspberry supports analog TVs also. Now, audio output. If you want to produce a sound-based system, that means you want to play a song, you want to make announcements using RPie, yes, RPie provides an audio output. So it provides a jack, it connects an audio output device such as headphones or speakers. You can directly connect a speaker to the audio output, play a song, and can produce a sound output from a Arduino. LEDs, light emitting diodes for all of your indicator LED needs. So that means that these are some of the LEDs which are available on the RPie to give certain indications. For example, when you give a power, when SD card reading, there are certain LEDs are there which gives indications. That is only for whether the RPie is working properly, whether booting is happening. So such indications you can get through an LEDs. That is an advantage with the RPie board. You can make a lot of observations by just looking at these LEDs. Now, USB. So there is a common connection port for peripheral device of all types, including your mouse and a keyboard. Model A has 1, Model B has 2, B plus has 4. You can use USB hub to expand the number of ports or plug your mouse into your keyboard if it has its own USB port. As I said, the USB whatever provided here, the USB whatever provided is act like a host and a device also. In the sense, whenever you use USB, we use always here two things. One is a host, other is a device. And also we use a word called OTG, on the go. What does it mean that? For example, if you take Arduino board as a microcontroller, I will hook Arduino microcontroller to my computer. Whenever I connect Arduino microcontroller to my computer, Arduino board becomes a device. It is not a host. Who is a host? Your laptop computer is a host. Arduino board becomes a device. Arduino board does not have the capability to act as a host. So whenever you are able to connect other USB device to your board, your system, then it becomes a host. For example, so it's very clearly specified here. That means that you can able to connect so that means I can able to connect other devices into my Raspberry Pi board. That means that I can connect a mouse, I can connect a keyboard. That means that my Raspberry Pi system is acting as a host also. So whenever you provide a host facility, it becomes a computer. This facility is not, even though USB port is available in Arduino, it is not a host. And earlier systems has only few USB ports for that. Now latest has given up to 4. But many times we feel those USB ports are shortage. Whenever you feel USB ports are shortage, you can always go for USB hub and expand the USB number of ports. So this is a way we can able to use it. Next, HDMI. So nowadays, most of the high definition televisions are the digital televisions which are available in the market. So I cannot just use ordinary analog TVs. I have a new television, or I have a new monitor which has been used for a normal desktop computer. I want to use a monitor, the latest monitor which is used with a desktop computers. I want to connect to this one. Yes, it's possible because they provide HDMI port. So HDMI port supports high definition digital televisions to be connected to here. So that means that when you want to build a project, you want a perfect display system, so which is also cheaper, because normal embedded system displays are costly. If you take LCD 2 lines, it's cheaper. But if you want to go to the bigger displays which are compatible for the microcontrollers, it's becoming very costly, and it's not commercially available, as you cannot walk into the SP road and purchase the bigger displays for microcontroller based systems. It should be imported, or very few companies are there, or if it goes bad, you cannot replace it. Whereas if your embedded system, if you use normal monitors which has been used for a desktop computer, is always a good selection, because why? For 4,000 rupees, normal monitors used in the desktop computers are available in the market. So you can always use normal monitors to build an embedded system project, because why? They are available in plenty in the market, and RPie supports HDMI port. For example, you cannot connect a digital monitors to an Arduino or a Node MCU. It's impossible. You can only connect what normal LCDs using SPI protocol, or you have to use some digital pins so you can send it. So if you want to connect HDMI port, you require HDMI controller. So in this board here, HDMI controller logic has been inbuilt. That in the sense, HDMI interface has been provided in this board itself, hardware. That is why I can connect it to here directly. That's an advantage of this board compared to your Arduino or this one. So summarizing, you can say that RPie supports both analog monitors and both the digital monitor. Analog monitor, you to use a jack, RCA jack. For digital monitor, you to use HDMI port. Anything you can able to use, depends upon the project. Now coming back. So power. How do you power Raspberry Pi? See, normal desktop computers, you cannot power from a battery. You cannot power from a normal 5 volts adapter in the market. Can you run a normal desktop computer with an adapter? It's impossible. Yes or no? Of course, laptops can use it because of the two specific adapters you have to use. It's not like that. Here, a standard 5 volts micro USB adapter has been available in the market, which is used for a number of microcontroller boards. Today, number of microcontroller boards work on a 5 volts USB adapter. So only thing is you have to take care is what? The power requirement for driving Arduino board is different. The power required for driving the RPie is different. In RPie, you require at least 1 amp, 1.5 amps. It's better to go up to 2 amps, because some of the, if you run computational intensive applications you want to run, you want to capture the video, it consumes little power. So only thing is you require an adapter, 5 volts adapter, but don't use an adapter of lower amps capability. At least go for an adapter which has got 2 amps. If they say 2 amps, at least they provide more than 1 amp. So you require an adapter, 5 volts adapter. From that, you can able to power your RPie and make it work for all of your applications. SD card. Now, this is an important component of an RPie. This is a full-sized SD card slot. An SD card with an operating system installed is required for booting the device. They are available for purchase from the manufacturers, but you can also download an OS and save it to the card yourself if you have a Linux machine and wherewithal. So if you look at that, the board, you require an SD card. You can purchase an SD card. See, when you want to order for RPie, you can order for RPie along with an SD card loaded with the OS, you can order for it. Or what you can do is, you can go to the SP road, or you can order only for the RPie, separately purchase 32 GB hard SD card from the local market. You can only, there are softwares available both in the Windows and the Linux. Through that software, Windows installers, you can take the OS image from the RPie website, and you can burn that image, OS image, into the SD card. So both options are there. Either you can purchase SD card loaded with the OS, or you can purchase an SD card. You can only download an image using a proper software. You can able to burn that image here. I recommend the second one because you learn a lot of things from that. So then once you load an image here, that is an OS image, you have to put the SD card in the backside. Here you can see that the backside SD card can be placed here. So once you place the SD card on the backside, so there is a way where you can place SD card slot, micro SD card slot on underside. So you can see that on the below side, on the bottom, they have provided SD card slot. So where you can able to provide, keep an SD card. So whenever you give a power, it boots from the operating system loaded on the SD card. It is not from a hard disk. Normal desktop computer boot from hard disk. Normal laptop boot from a hard disk present inside. That means that they load the OS from where? From hard disk, and then bring it to what main memory, and then they run it. So it's not like this. Here, there's no hard disk is present here. SD card is a secondary storage device here available here. So on the SD card, you have to load your OS. From that, OS will be booted. So where is the storage? Then I'm writing my programs. I'm storing my database. I want to install my SQL server so that I can store some data in a database. Where do you store? Same SD card. This SD card, whatever you have, it is used for both applications, either to store the OS also. After the OS, there's a lot of space is remaining. In that, you can able to download your applications. You can write your data, create a text file, create a database files, so that you can able to later take that SD card and upload it to a computer, or without removing that, there's a lot of ways you can connect to a computer and you can upload that information to a normal computer also. So this is the application of an SD card. So next, Ethernet. So Ethernet connector allows you a wide network access and is only available in the Model B. So it's not available in all the Arduino, all the RPie boards. Make sure that whenever you want to establish connection between the multiple RPies or RPie and other computers or other network devices using a cable, using a LAN cable, then you have to go for RPie, which has got an Ethernet. Now summarizing, if I ask a question, describe the different components present on the RPie board. Summarizing, what should I say? So RPie is being driven by BCM28335 system on chip. So plus it has got a GPU capability. RPie provides 40-pin GPU pin to connect to the external devices. RPO provides RCA jack and HDMI connector to connect analog devices and also digital monitors. RPA provides audio output so that I can able to play the music. RPA provides LEDs to indicate the functioning of the board, whether the booting is happening, whether the board is working. RPA provides the USB ports to connect to the external devices. RPA provides an SD card slot where my OS is loaded, my application program is loaded. RPA provides both the Wi-Fi and the Ethernet to support the network infrastructure. So these are the different components, what is present on the RPie. So look at this board. So number of facilities are present in a single board computer. I'll tell you, this is the really great innovation of the century, because it enabled a lot of people to come out with a number of products which would have been impossible without an RPie. So you can see that processor, the Broadcom processor here, it's printed here. You can see the Ethernet support. You can see analog interface. You can see HDMI interface. You can see 5 volts micro USB. Micro USB, that is where you can connect a power. The below is an SD card. There's a power supply section. What is power required? From the 5 volts, you derive the different voltages required for the system on chip and other peripherals. So this is where the camera interface is also provided. Your CSI camera connector. If there are cameras with the CSI interface, you can connect the directly camera to here. There are two ways there. If you go for a USB camera, you can connect to the USB port. If you want a CSI interface camera, you can connect it to a camera here also. You can able to connect it. So this is the Ethernet port. So this is the details about RPie. This is one of the model I have taken in between the model, that is a Raspberry 3 Model B plus, and the picture I'm showing it. And these are the features of those models. These are the components you're supposed to order it whenever you want to go for RPie based project. Not everything is required. Nowadays, latest RPie has got a Wi-Fi so that you don't require this one. So USB microphone, if it's required, you can go for it. Otherwise, it depends upon the application. This is required. So this is required. So GoPro wall mount, if at all, if you want to install as a product on a wall, something, you can go for that. So otherwise, so these two are essential. Only if you go for these two, then all other things, if required, you have to go for it. Is it audible?
Yes, sir.
Okay. Are you listening?
Yes, sir.
Okay.
Yes.
So now we will see the generation of RPie. What are the different RPie versions available in the market? Whenever I go for a market, which version I have to go for it? Or probably your senior would have given an RPie. How do you identify which version it is and what facilities it has got? So RPie are released to the market in 4 different generations. Like we saw Windows 98, So Windows 2000, then Windows now, the latest version, whatever available. So let's say the different versions of Windows, no? So RPie also comes out in different versions. The first RPie is released was generation 1 RPie. So it has got a model B plus. They call it as a Raspberry Pi model B plus is a final version of the original Raspberry Pi 1. So Raspberry Pi 1. So what is the final version? They have released 2-3 models. The final model of the generation 1 is model B plus. So look at that. The memory is less now. Now it's 8 GB RAM, latest version, 512 MB RAM. So 4 USB ports, 40 GPIO pins, an Ethernet port. Raspberry Pi model A plus is the low cost variant of the Raspberry Pi 1. So it has 512 MB RAM, 1 USB port, 40 GPIO pins, and no Ethernet port. So BCM2835, ARM11, so 6 core at 700 megahertz, video core, 4 GPU. So these are the, so in the generation 1, they had 2 Raspberry Pi. One is called as a Raspberry Pi model A plus, the other is called Raspberry Pi model B plus. In the generation 1, if you want the low cost, nowadays is available. In some of the websites, they are selling the old Raspberry Pis for the very low cost. If you, for your application, if sufficient, you can go for that also. So generation 1, 2 models are there, model A plus and the model B plus. So model A plus do not have the Ethernet. So if you want Ethernet, go for a B plus. Then generation 2. So Raspberry Pi 2 shares many specs with the Raspberry Pi 1B plus, that whatever you provided in the 1B plus, they provide that one. And originally use 900 megahertz quad core ARM Cortex A7 CPU and has 1 GB RAM. So what is an advantage of a generation 2? So here it is only 512 MB RAM. They have increased to in the next generation 1 GB RAM they have provided. So, and the next is, and they work at a 900 megahertz. The first generation working was a 700 megahertz. So the second generation, they improved the speed also, 900 megahertz. So more recent versions of the Raspberry Pi 2 use a 900 megahertz ARM Cortex A53 CPU. So in the generation 1, they have used which processor? They have used BCM2835. In the generation 2, what they have used? ARM Cortex A53 CPU they have used, and 1 GB RAM they provided. In the generation 3, it was very popular for a long time. People use generation 3 controllers. RPie 3 model B plus uses 1.4 gigahertz 64-bit quad-core ARM Cortex A53 CPU. So look at that. In the generation 2, they have used only ARM Cortex A7 CPU with a 900 megahertz capability. Here in generation 3, what they made? They made it run at 1.4 gigahertz, and they made it 64-bit also, and it's a Cortex A53 CPU. They've used it. Of course, memory same, 1 GB RAM, gigabit Ethernet. They've used it. The speed of Ethernet communication, that is speed of your network communication, is better compared to generation 2. So they have provided wireless LAN. So in the generation up to generation 1 and 2, the no Wi-Fi facility was there. In generation 3, along with a wired LAN, they also provided wireless LAN, and also they provided a Bluetooth. If somebody asks, what is the difference between generation 2 and generation 3? You can immediately tell it runs at a higher speed, 1.4 gigahertz. It supports both the Wi-Fi and the Bluetooth. That is an advantage of a generation 3. In the generation 3, the latest model, there are 2 models are there. 3 model B and B plus, 2 models are there. So model B is a lower version compared to the model B plus. So B plus is the higher end model of the generation 3. Now this is the latest model. Model 4B, RPie model 4B uses 1.5 gigahertz 64-bit quad-core ARM Cortex A72 CPU. Look at that. So here they've used BCM2835 700 megahertz. Next they use ARM Cortex A7 900 megahertz. Next version they have used Cortex A53 1.4 gigahertz. So with a quad core, here look at that. It is 64 quad core, but runs at what? 1.45 gigahertz, and the processor is better. Which is here A53 is a ARM Cortex A72. That means that CPU capabilities has been increased, the power from the lower first generation to the latest generation. Now it has a 3 RAM options, 2 GB, 4 GB, 8 GB, which was not supported in any of these below versions. All these, for example, up to generation 3, only they supported 1 GB. That is why RPie 4 is very popular for computational intensive and a lot of graphic processing wherever is required, image processing is required. People go for always generation 4 because it provides what? 2 GB, 4 GB, 8 GB, depends upon the money you pay. So the highest is 8 GB it supports. It provides like a gigabit Ethernet and integrated wireless LAN and a Bluetooth 5.0. It's a Bluetooth 4.2, here a Bluetooth 5.0 it provides. So these are the variations of the generations and model. You should be able to understand. If somebody asks, how many generations are RPie is there? There are 4 generations there. Generation 1, 2, 3, 4. What are the differences? From the generation 1 CPU capability, CPU speed has been increased. So starting from BCM 2835 to the latest ARM Cortex A72, the different controllers, that is, the different system on chip has been used. The power has been increased. Next, the RAM. Initial version has got only 512 MB RAM. Now it has reached to what? From 512 MB to 8 GB it has reached, enhanced. Now, what about the Wi-Fi and the Bluetooth? The Bluetooth latest version, latest standard, Bluetooth 5.0 has been implemented into the latest generation. That's the generation 4 RPie boards. So these are some things you should be able to remember, that if somebody asks, or you get a board of a different version, generation, the moment you get RPie into your hand, just look at what is the model number. Is it Pi 1B plus? Is it Pi 3B plus? Or it's a Pi 4B? Like that, you look at the model. The moment you look at the model number, then come to this PPT screen, just analyze that, how much of memory you have, how much of capability for the networking it provides, then you have to take a decision. I suggest if you're doing a simple project, you can go for generation 3. If you're going a lot of image processing, always go for a generation 4. It depends upon the cost. If you're able to get generation 4 at the cost of 3, always better to go for a generation 4. Only thing is power consumption will be always is more as you move from the lower generation to higher generation. That is the one thing you have to keep in mind. So you have to measure the power consumption for your project. For your project, always go for a, if you're deploying in a remote places, go for a version or generation which consumes lesser power, because you have to run your model, you have to run your the whole project on a battery many times. Apart from these generation, there's one more latest version of RPie is available. We call it the Raspberry Pi Zero. If you want very low cost and very small size, I don't require Ethernet, I don't require multiple USB ports, I require only for certain image processing and controlling, please go for RPie Zero. It is the best suited for many of the projects. RPie Zero and RPie Zero WWH. So that is only RPie Zero, you don't get a wireless. RPie Zero W/WH provides what? Wi-Fi capability. So you can purchase RPie Zero whether with Wi-Fi or without Wi-Fi, or half of the size of the model A+. Since the size is less, the power consumption is very less, and feature 1 GHz single core 512 MB RAM. This is the limitation. So if you want very high computation, you want 1.5 GHz multi-core, go for RPie Zero. Now for my application, single core is good enough, 1 GHz is good enough, go for this one. And the RAM is also less. If you go for RPie 4, you can have up to 8 GB RAM, whereas if you go for RPie Zero, you can get only 512 MB of RAM, you can get it. And it provides a mini HDMI. It's a mini HDMI. No, not that. It's a mini HDMI, not a normal HDMI. And USB on the go, OTG. I said no. USB OTG means on the go. On the go means the same USB port acts as a device also. The same USB port acts as a host also. Any USB port which has got the capability to act as a host and a device, we call as a OTG capability. And a camera connector is also available. Raspberry Pi Zero W also has integrated 802.11n wireless LAN and a Bluetooth 4.1. The Raspberry Pi Zero WH is identical to the Zero W, but comes with a pre-soldered header. That means that, so WH means H is there means, H means that is header is soldered, that is pins are soldered on that. If H is not there, that pins are not soldered, you can solder the wire directly, you can solder the component directly here, that is a component pins using a jumper wires, you can solder here, or you can solder only the pins what is required. That is this one. So these are the versions about the Raspberry Pi. So summarizing, Raspberry Pi comes with the 4 versions, generation 1, 2, 3, 4, and one more version is called Raspberry Pi Zero. It comes with a Wi-Fi or without Wi-Fi, without header or with the header you can able to work. This is about the versions. So summarizing, so RPie has got, so it's a single board computer which provides the following components. RPie comes with the 4 versions and the 0 versions. So now we will go to little more detail in the board. So now we have understood the different versions, different capabilities of RPie. Now let's start using the RPie. Is it okay? Shall I continue? Hello? Shall I continue? Hello? Hello? Hello?
Yes, sir.
Shall I continue?
Yes.
Okay. Hope you're listening. So now what we do is we will understand now how to build projects using RPie. What is basically required for a hacker, hardware prototypist, hardware practitioner, or the person who builds embedded systems. Always you should first look at the pins. What pins are there? How do I connect my projects to these pins? How do you use them? This is my first requirements. There are 40 pins are there. You can look at the naming 1, 2, 3, 4. These are the numbers printed on the board. This is one numbering system is there. The same, look at the pin number 3 here. There's one more naming called GPO2. So that means that same pin I can call by two names. One is the 3, one is GPO2. So two numbering systems are generally followed by the programmers who use the Raspberry Pi. What are the two numbering systems? One is a board numbering system. Board numbering means the numbers printed on the board next to your header. Other numbering system is the numbers based on the microcontroller chip what has been used on the board, like a BCM, whatever the Broadcom chip. So these are the chip based. These are the system on chip based numbering. That is the numbers with reference to the microcontroller system on chip. These are the numbers with reference to what? The board. Either I can go for board numbering or I can go for the system on chip numbering. So we have to specify whenever we write a program in a Python and a C language, I should specify in the beginning of a programming, am I using board numbering or am I using the system on chip numbering? That is the one thing you have to take care. Now, all these pins, whatever you have, I can classify into following types. What is the way I can able to classify them? So now I will go for a board. Is the board is visible? Is my writing tab is visible?
Yes, sir.
Okay. So now I will explain with reference to this, what are the pins we have it and how do we use them actually in that. Now, so if you look at the RPie, the number of pins, whatever it provides, these pins are classified into 40 pins are there. Totally, how many pins are there? Totally, the 40 pins are available. 40 pins are available as a GPU header. Now, as I said, numbering can be what? Either a board numbering I can follow for that, or I can say system on chip, SOC, board numbering I can follow for referring to this pin, or system on chip numbering I can follow. Any one of these numbering follow. So these pins, whatever the days, one is called as, I can use them as digital input output pins, digital IO pins. So if you look at this figure, you can see that there's a lot of GPU pins are there. GPU 1, 2, 3, 4, 17, 27, 23, these pins are there. That means that I have number of GPU pins are available. These GPU pins, I can use them to connect the different devices. What type of devices I can connect it? I can connect only digital input devices, digital input devices. That means that no analog support, no analog input is available. So this is important. Whenever you want to go for Arduino, you cannot read the sensor directly. For example, temperature sensor, connect to the Arduino? No. Analog input is not provided here. So that means that you have to use an ADC, analog to digital converter, convert them into the digital format, then you have to read it. Or go for a sensor which is capable of converting analog to digital inside and send the data to the RPie using a digital format. That you have to keep in mind. Now, so we have understood that it does not have a support for analog input. Then what is the power supply it provides? You can see the ground is available here. Ground pin is available. Then you have what is called as 3.3 volts voltage available, 5 volts available. So I have a power supply. Pins are available, power supply pins. So what are the power supply pins it provides? It provides plus 5 volts, plus 3.3 volts, and the ground it provides. So these are pins are similar to what you have seen in the Arduino also. In Arduino also you will get 5 volts, 3.3 volts, ground. So these are the 3 power supply pins are available. Next. So if you look at these pins, what is an extra things you have here? I said, whatever you have seen on the other side, alternative function. What does it mean, alternative function? That means that these are the functions you can perform alternately. These are the functions you can perform alternately along with the GPU. In a sense, I can use pin number 3 and 5 as a GPU pin to read digital input output devices, or I can use the same pins to perform this job. This is an additional job, alternate function. So this one additional job, this is another additional job support is provided, and this is again another additional job is being provided. So in a sense, so I can summarize total what are the alternate jobs it can perform. Number 1, 2, and then here also there's another alternate job. Well, it's not an alternate job, it's another job apart from a GPU pins it's provided. So let's write those functions. So it provides a lot of serial protocols. It provides serial protocols. What are the serial protocols? These are the embedded serial protocol. So in the sense, almost all the embedded systems or hardware prototyping platforms uses these protocols. It is required. If you don't provide these protocol, you cannot interface many of the sensors available in the market. That is why if I say it's a single board computer and it is like a microcontroller, why I will call it a single, it is like a microcontroller? Because this provides serial protocol. Can a normal desktop computer or a laptop, does they provide these serial protocols? No. Normal laptops provides only USB or Ethernet or Wi-Fi. They do not provide serial protocols useful for embedded systems. That is why RPie is different from a normal desktop computer or normal motherboard, Intel motherboard. Intel motherboard do not provide the serial protocol, whereas only single board computer, which is used to build hardware prototyping platforms or hardware products or embedded products, provides the protocol. What are the protocols? It provides I2C protocol. It provides SPA protocol, two devices, 2 SPA slots available, SPA 0 and SPA 1 is available. So 2 slots available. And then it provides what is called Uart. So Uart already we have seen that in case of an Arduino, TXD and RXT. So using Uart, you can connect the GSM module, GPS module, all those things you can able to connect. Using I2C, you can connect a number of sensors you can able to connect. So using SPI, you can connect the displays, the normal LCD displays, you can connect it. SD card, you can extra display, extra storage, you can able to connect it here. Uart, you can connect the laptops or other microcontroller boards, you can able to connect it here. So that means that, so these are the different support provided by your RPie 40 pin header. Summarizing, 40 pins are available as in the GPO header. They are numbered as a board numbering, or they will be numbered as SOC numbering when we write a program. All the 40 pins are grouped into following 3 types. One is the digital input out pins. They are used to connect the digital input output devices. No analog input or output are supported on the RPie board. RPie provides a power supply to power the external sensors. They provide the power 5 volts, 3.3 volts, and the grounds. RPie supports embedded serial protocols like an I2C, SPI, and Uart, so that you can able to build a lot of prototyping using RPie. Now, so going back to the slide there. So now we have understood that. So how RPie provides a 40 pins. What are the details I have understood now? So once I have understood now the GPU pins, now it's a time for me to build the projects. For hardware hacking, the Pi is equipped with the 40 general purpose input output pins, electrical channels that allow the board to communicate with other computers or electronics, and are the key to the Pi's use in some of the more ambitious hardware projects involving robots and drones. Getting started with the hardware is relatively easy thanks to the abundance of starter kits that bundle the boards and other electronics you need. Now, let's start with the coding. Now, I have purchased an RPie board. I have installed the OS on the SD card. I have placed the SD card on that. The moment you install the OS onto that, whatever the OS, RPie, Raspbian OS, which has been downloaded and placed in the SD card, has got an inbuilt Python compiler. You don't require to install the again Python. Python compiler is inbuilt. Since you know that once you have an OS available here, what do you get when you boot? RPie is like a Linux-like OS. The boot, you get a dollar prompt. That means that like whenever you start a Linux computer, what do you get? A dollar prompt. On the dollar prompt, you can start giving instruction to your Linux computer, that is a RPie board, and you can write your programs and run. It is like a normal computer. Once you start connect your monitor or connect your laptop screen to your RPie board, you can program the way you want it. We will have one more session about installation of RPie 0 itself as a separate installation. So today I will assume that RPie 0 is booted and you got a prompt symbol and Python compile is loaded. I want to write a program. What is my first program? I will connect an LED to the RPie 0 and write a program to make it on and off. It's a simple Python code. You don't require much of the learning. You can just practice like that. What are the first thing I have to do? As I said, the numbering what is provided is different. The numbers what is printed here is called as a board numbering. The numbers what is shown is called as a chip numbering. I'll be using a board numbering. That is why this statement is there. So this is a chip numbering. So I'm using chip numbering. So I'm using a chip numbering. So this is the first thing you have to do. That means that I am numbering all the whatever the numbers I refer in the program, they are referred to what? Board numbering. This is numbering. So pin number 13. The pin number 13 is GPIO pin. So I have connected an LED there. Anode with a resistor. I have connected to ground. This is a ground pin. I've just connected it. Now, whenever you have to use any GPIO pins, after identifying the number system, then you have to do the next thing is what? Whether I'm using the pin for input or output. This you have to say that this we were doing in the Arduino also using a set pin. So in the using a pin set, so pin mode we were setting there, indicating is an input or output. So here also you have to set the pin mode. So when I say 13 GPIO output, I'm using this pin for output. This is very essential. If you don't do this, it will not work properly. You will not get the expected result. Now, I've written a small program in the Python. So since I have imported a library, RPO, GPIO library, I can able to refer the functions provided by the GPIO object. So GPIO.output. So pin number I'm referring it. The pin number is what? 13. True. True means 1. So LED is on. Sleep for a moment. Again, make it off. Sleep for a moment. So since it's a while true, this will be continuously executing it. So if you want to give instead of 13, you want to give a name for that. So you can say you can give a name for that LED number something. Instead of 23, you just type 13 here, and then I can use instead of 13 the name. I can be able to use it. This is how we can able to connect an LED to a header and write a program and run this program. You can see on the RPie is controlling an LED. Now let's go to the next program. If I want to write, see, RPie supports both the C also and also Python also. You can write in a C also. If you want to write in a C, you know that in the Linux, how do you run a C? Same compilers you can use to run the C program. If you want to run a C, what do you do? First, as usual, studio.h include. So these are the two libraries you have to include, wiring.pi.h. So the moment you include this header file, it's already bundled with the when you install the OS. Then I'm just using the pin mode as an output port. I'm using 5 LED connector pin 5 here, then digital write. So, and then digital write, delay, and then the while loop. So you can write a program either in the C language or you can write a program in the Python also. So this is how you can able to write a program in the C language. So I have given both the programs for the Python also, C also. Now, let's say I want to connect a switch and make, when I press the switch, the blinking of LED should happen. So now what I say, I've just selected the board, the numbering system. I have connected the pin number 3. I'm using the pin number 3 on the board to connect a switch. So I have set up the switch as an GPIO input because the switch is a kind of input device. Then LED, I've assumed that is a 23, pin number 23. So after that, I'm just reading it. If the switch is true, that is you press the switch, then output LED. Otherwise, it's a false. It will be in the loop. So I have connected a switch to the board at the pin number 3. I have connected LED to the 23. I am reading the switch. If the switch is pressed, then I am making the LED on, otherwise off. So like this, I'm able to connect now input device also output device. So what are the functions I've used? I've used a GPIO input function. I've used a GPIO output function. I've used a GPIO set mode function. I've used a GPIO setup. So these are the 4 functions we generally require in a Python to write the program: GPIO output, GPIO input, GPIO setup, and the set mode. So these functions are a part of a library. If you import this one, these 4 functions are available. So this is how I'm able to use them actually. So now I want to do a small project now. So using a Raspberry Pi, I want to connect one of the popular sensor available in the market. That's called a Dht11 sensor. So after connecting the sensor, now what I'll do is I'll stop it here. I think so.